Okay, today we're going to take a look at how to do limiting reactant problems. Limiting reactant problems are different from other stoichiometry problems that we've done before in that rather than just giving you the amount of just one reactant, these problems will give you the amounts of two or more reactants that are involved. And you need to figure out what to base your product amounts on. So the best analogy that I can kind of give is something like this. So suppose you want to build cars and you know how many car bodies you have to start with, and you know how many tires. You have 8 car bodies and 48 tires. And the question becomes, well, what is the maximum amount of cars that you can make? So really what you would have to do is you would have to consider each of your starting materials and kind of think about, well, how much product can I make starting with each of these things? So for the 8 car bodies, I can make 8 cars. Okay, for the 48 tires, I can make 12 cars because for each car you would have 4 tires. So it comes to show us that really the maximum amount of cars that I can make are 8. It's the car bodies that are limiting how many cars I can make. It's my car bodies that we would call the limiting reactant. And the other starting material, the other reactant, I would not end up using all of it. I would have some left over at the end of the process. If I make 8 cars and I start with 48 tires, I'm going to end up having 16 tires left over, and we would end up calling the tires the excess reactant. Okay, so one of our reactants is limiting, the other reactant or reactants would be in excess. So we're going to apply the same kind of problem solving technique to a chemistry problem where we are going to take each of our starting materials, each of our reactants, and figure out how much product can I make with each of them. And whichever gives us the least amount of product is going to be our limiting reactant, and the amount of product that I can make from that limiting reactant we call the theoretical yield. Okay? So let's just get right into a problem. Okay, so let's say I have 10 moles of hydrogen and 7 moles of oxygen in a container, and I know this is the reaction of hydrogen gas reacting with oxygen gas, as I can see here, hydrogen gas reacting with oxygen gas, and this is a balanced equation. And I want to know what mass of water can be produced. And sometimes we call this, again, the theoretical yield, which is really a fancy way for saying what's the maximum amount of product I can get from these two starting materials. So what I'm going to do is my plan is I'm going to take the 10 moles of H2, the 10 moles of hydrogen gas, and I'm going to do out almost like one stoichiometry problem, just converting the 10 moles of hydrogen gas into my product. Okay, and then I'm going to do the same exact steps, except I'm going to be starting with 7 moles of oxygen gas, turn that into my product, and I'm going to see which starting material gives me the least amount of product, and whichever does is my limiting reactant, and whichever is my limiting reactant, that's really going to guide how much product I can make. What's the theoretical yield? In this case, there's only one product. So I'm going to turn each of these starting materials into water. If there were 2 or more products, you can feel free to turn them into, you can pick one of the products that you want to turn it into. Just make sure you pick the same product. Okay, so I'm going to take my 10 moles of hydrogen gas, find it in my reaction, here it is. As long as I'm in moles, I can go ahead and do stoichiometry, meaning I can use the coefficients to change from one substance into another. So I want to change the hydrogen gas into water, so I am going to do stoichiometry here. There's 2 moles of hydrogen gas producing 2 moles of water according to my reaction here. And the moles of hydrogen gas are going to cancel out, and I'm in moles of water. Since they asked me in the problem what's the mass of water, I'm going to take this one step further, and I'm just going to change from moles of water into grams of water. And if you need more help how I'm getting these numbers, what I'm doing here, go back to my video about mole conversions and stoichiometry so that so I don't have to repeat myself here. Okay, and really here I'm just massing it out. I'm changing from moles into grams of water. Okay, and in my calculator I get my answer, or in my head I can do this as well. I get that there's 180 grams of water produced starting with 10 moles of hydrogen gas going through this reaction. Now, I don't just start with 10 moles of hydrogen gas. This is a limiting reactant problem because I see that there's more than one starting material amount given. So I've got to now take the 7 moles of oxygen gas, and in a separate stoichiometry, I'm going to convert that into product. Just like how we do with the cars, we're taking each starting material, turning it into product, and we're going to see which gives us the least amount of product. That is what will limit us. Okay, so I'm going to take the 7 moles of oxygen gas. I'm in moles already, so I can go straight to my coefficients, and in a stoichiometry step, I can convert moles of oxygen into moles of water. Okay, and let's mass it out since they asked for a mass, which I really don't have to. I could just compare mole amounts, but we might as well get into mass right away. And I get that 252 grams of water are produced. Okay, so what is my theoretical yield of water? Well, that would be the smaller amount. Okay, this is the amount of water that theoretically is the maximum that could be produced. And that the 10 moles of H2 is actually my limiting reactant. The 7 moles of oxygen would be in excess. Okay? So just remember, even though it says a lot of times we want to pick the bigger amount, it's really the smaller amount. That's what's limiting you. That's the most that you can make. Okay, I don't have enough hydrogen gas to actually react with all the oxygen. I'll never get up to 252 grams of water. Okay, another example here, if you're given gram amounts to start with, that's fine. You could be given any units to start with. Just make sure that when you are touching those coefficients that you are using your, you should be in moles for the most part. Okay, so in this situation, they give me 16 grams of hydrogen and 40 grams of nitrogen. So I'm going to take each of those amounts. I'm going to do almost like separate stoichiometry problems to turn each of those into the product, in this case ammonia. And I'm going to see which one gives me the least amount of ammonia. Okay, so with stoichiometry, since I'm starting with grams, when in doubt, we mole it out. So we got to be in moles to touch these coefficients in order to change from reactant to product. Okay, so I first got to use the molar mass of H2. There's 2 grams for every 1 mole. Okay, I'm moling it out. Then I can convert from hydrogen gas into ammonia with stoichiometry, 3 moles to 2 moles. Okay, I want the H2 on the bottom so that it cancels out. Now I'm in moles of ammonia, but since the problem asked me for mass, I might as well use the molar mass and convert this right away into mass. Again, I could have just stopped here and gotten a number, and I can compare mole amounts as well, but since it asks for mass, we might as well use 17 grams for every 1 mole, and we get that 90.7 grams of NH3 could be the maximum produced if I start with 16 grams of hydrogen. Okay, assuming that I would have enough nitrogen to react with all this. Well, let's see what I would get starting with 40 grams of nitrogen. Let's figure out how much product I can make here. So again, I'm in grams, so let's mole it out. Okay, using 28 grams per 1 mole. Nitrogen's diatomic. It has a subscript of 2, so don't forget that the molar mass will be 28 and not 14 here. Okay, now I'm in moles of N2. Now I can convert from moles of N2 nitrogen gas into moles of ammonium with a 1:2 ratio. Okay, and since they're asking me for mass, might as well mass it out. And now I get that 48.6 grams of ammonia could be produced. Okay, again, just make sure that once you get your product amounts, you're in the same product and the same units. So let's see, what is my limiting reactant? And what's my theoretical yield of ammonia? Well, my limiting reactant is the reactant that produces the least amount of product. So my limiting reactant would be the N2, the nitrogen gas. And my theoretical yield of ammonia, my most amount of product that could theoretically be made, is 48.6, because this is the smaller amount here. Okay. Now there might be side reactions happening, or not all of it might react. So we say this is the theoretical yield, meaning theoretically this is the most possible. We might in an experiment actually get less than this. Okay. And another problem here. Okay, 2 grams of ammonia is mixed with 4 grams of oxygen, and I give you this reaction here, and notice there's 2 products. Okay, if there's 2 products, feel free to pick either product to turn it into. I like to continue reading the problem and seeing what's asked, and I choose the correct one to turn it into. That would save me time, but you can actually pick either nitrogen oxide or water here to turn this into. Since part B asked me for NO, I guess I could turn them both into NO first. But it asked me for H2O later on, so either is fine. So in this case, again, I take each starting reactant and I take them and each turn them into my one product that I pick, in this case NO. And again, this is one you might want to try on your own first. Pause the video where that problem is, and now you can check your work. And I get that 4 grams of oxygen, the oxygen gas, is my limiting reactant, and that 3 grams of nitrogen oxide or nitrogen monoxide is your theoretical yield here. And once they ask me for any other amounts of product or any other theoretical yields, don't bother doing these 2 steps again. The rest of the problem can be done based off of the limiting reactant. Okay, so when they ask me for part C, the grams of water that can be produced, I'm going to take the 4 grams of oxygen gas, and I'm just going to go ahead and turn that instead into water, my other product. Okay, and then mass it out, and then I get 2.7 grams of water. I don't have to go ahead and do 2 separate stoichiometry problems again like I did to start with. Okay, and part D, how many grams of excess reactant remain? Okay, when you're figuring out the excess that remains, the first thing you want to do is you want to take your limiting reactant, and you're going to use stoichiometry to figure out how much of the excess reactant will need to react with it. How much would get used up. Okay, and then you can subtract that amount from the starting mass, and that's how much would remain in the container. And I always suggest just make sure you read the problem. Are they asking you in the problem how much excess remains? That requires a subtraction. Or are they asking you how much reacts? And then you don't need that extra step. Okay, so again, in this example, we had found that the oxygen gas was the limiting reactant. The ammonia is the excess reactant. So let's take the limiting reactant. Again, once you find the limiting reactant, really the entire problem is done based off of that. Okay, so I'm going to take the 4 grams of oxygen, and since they asked me about the excess, which is the ammonia, I'm going to take these 4 grams of oxygen and turn it into ammonia. Again, I'm in grams, so we mole it out. And you might have somewhere along the way have gotten the moles, and you don't have to do this whole long step of stoichiometry. Or you might cut some of this short. So I have 4 grams and turning it into moles. Now I'm taking my moles of oxygen, my limiting reactant, and turning it into moles of ammonia. Okay, so here I am with my stoichiometry of 4 to 5 ratio here. Now I'm in moles of ammonia. Since they asked me about mass or grams, let's mass it back out using the molar mass, 17 grams for every 1 mole. And I get that there's 1.7 grams of ammonia. That's how much will react with the oxygen gas. That's how much is going to get used up with the limiting reactant, because remember, the limiting reactant, we're not going to have any of that left in the container. The excess will remain. So if 1.7 grams react, and if I go back to the problem statement, I see 2 grams I had to start with, how much would remain? Well, we would just subtract, and we would see that 0.3 grams remain. Okay, so again, read your problem. If they ask how much reacts, you just do another long line of stoichiometry. You just start with the limiting reactant and you turn it into excess reactant. That always gives you how much of the excess reacts, gets used up. If they ask how much remains, you subtract it from the start. And those are really most of the limiting reactant kinds of problems that you would see. Okay, you don't have to start with moles or grams to start with. Maybe you get to the ideal gas law chapter and you're starting with liters or pressures and things like that for gases. So whatever you do, really your first step is mole it out and in your long line of stoichiometry. Okay, and that's it.